All right, today we're going to be talking about Chapter 9, Lesson 6. It's about analyzing data distributions. So first thing we're going to do is we're going to talk about some words that we're going to be using and define them, and then we're going to use that information to help us with these problems. So first of all, a gap, a peak, outlier, cluster. We've kind of talked about some of these already, but a gap is where there are no data values. It's where there are no data values. It's an opening on a number line. It's where there are no data values. A peak it's where the most occurring number is. So this is kind of like the mode. It's where the most occurring number is. An outlier. We talked about this with our 5-number summary. But it's any number 1.5 times the interquartile range. So it's any number that's 1.5 times the interquartile range from the first and third quartiles, and it's outside. So any number that's outside of 1.5 times the interquartile range from the first and third quartiles. And then a cluster, a cluster is where there are many data points. And those are all grouped together. So those are 4 words we're going to use with our analyzing data distributions. The next thing we're going to be looking at is the shape of a distribution. So if we look at these 2 words here, symmetric and non-symmetric. A symmetric shape will look something like this. So a symmetric shape looks something along the lines of that, where it's very symmetrical around the peak. So 3 would be the peak, because that's the one that appears the most, and it's roughly the same on each side. A non-symmetric shape or distribution would look something like this. Where the peak is skewed either one way or the other, or shifted one way or the other. Excuse me. So let's utilize that information to help us with example 1. It says identify any symmetry, clusters, gaps, peaks, or outliers. Now, symmetry. This is all pushed to the right, so it's non-symmetric. Because everything is pushed to the right. Next is clusters. There's a large cluster from here to here. That's where most of the data points are located. So there's a cluster from 70 to 74. A gap appears between these 2 numbers here, 68 and 70. There's a gap in the data. There's nothing here. So we would say that there's a gap between 68 and 70. As far as peaks go, there really isn't a peak. Yeah, these 3 numbers are the mode. However, none of them really show a peak. So there are no peaks. And in this case, no number appears drastically far away from the majority of the data, so there would be no outliers. If you're not sure, you could always do the 5-number summary. The median would be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median would be 71. Interquartile range would then be from 70 to 72, so that's 2. 1.5 times 2 is 3. So we go from 70 minus 3 to 67. 67 is not outside. And from 72 times 3 would be 75, or 72 plus 3 is 75. Nothing is outside of that range either. 67 comes close, but it is not outside of that 1.5 times the IQR. All right. Now, this is where it gets a little bit more confusing. Sometimes we have to determine what kind of center and variability or spread we would use depending on what shape the distribution has. So, let's look at this. If it has symmetry, again, that's the one over here where it looked almost like a hill, or around the peak it's symmetric on both sides. If it is symmetric, what we would use is the mean and the mean absolute deviation to talk about our center and our variability, or our spread. If symmetry does not exist, where something appears to be skewed one way or the other, or shifted one way or the other, the mean would then be inappropriate, because the mean would be influenced by a lot of the values up here. So what we would use for our center is not the mean, but the median. Now, the spread that goes along with the median, think back to our 5-number summary, but it involves the interquartile range. So if there is symmetry involved, we would use the mean and mean absolute deviation. If there is no symmetry involved, we would use the median and the interquartile range. So if we look back at example 1, we said that this was non-symmetric, so we would use the median and the interquartile range in this case. For example 2, however, it says the ages of people in an exercise class are shown in the line plot. Describe the measures of center and spread and justify your answer based on the shape of the distribution. This shape is symmetric. Here is the peak, and it is symmetric on both sides. So because the shape is symmetric, we have to use the mean and the mean absolute deviation. Those are the two things that we have to absolutely use when it comes to describing this measures of center and spread for this set of data. So, the mean. We have 25. We have 2 30s. We have 3 35s. We have 2 40s. And we have a 45. Add up all those numbers, and what you would get is, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So 9 times 35 would be 270, and 45, so that'd be 315. And then the mean, there are 9 of them, so we would divide that by 9. So our mean is 35. Mean absolute deviation. Mean absolute deviation, we have to find the mean. We already did that. We then have to find the positive difference between each data value and the mean. So the main positive difference between 25 and 35 would be 10. Here would be 5. Here would be 5. And we have 3 zeros in a row. Another couple 5s. And a 45 to 35 is 10. Add up those numbers. 10, 5 and 5 is 20, and here's another for 40. That is the sum of all of the positive differences. There are 9 numbers, so again we divide by 9, and we will get about 6.7. Not 6.7. Excuse me. There are only 6 numbers that we involved here. These zeros we do not include. So we would do 40 divided by 6, and that will get you about 6.7. So the center is 35. That's where the data is centered around. And the mean absolute deviation, the spread around the center, is about 6.7 years. So you would say the data is centered around 35 years. And the spread of the data around the center is about 6.7 years. So if anybody has any questions, let me know. Otherwise, this is the end of lesson 6.